Ocean wave, how ocean currents regulate Earth's climate. Left magnifying glass, introduction. Ocean currents play a crucial role in regulating Earth's climate, influencing global temperatures, weather patterns, and marine ecosystems. These vast movements of seawater transport heat, nutrients, and oxygen across the planet, helping to stabilize climates and sustain biodiversity. Without ocean currents, many regions would experience extreme climate fluctuations, drastically altering global weather and life as we know it. From the Gulf Stream warming Europe to the Pacific's El Niño disrupting global weather patterns, ocean currents act as Earth's natural climate regulators. This article explores how ocean currents function, their impact on climate, and the potential consequences of climate change disrupting them. Ocean wave. 1. What are ocean currents? Small blue diamond, A, surface versus deep ocean currents. 1. Surface currents are driven by wind patterns, solar heating, and Earth's rotation, Coriolis effect, affecting the top 400 meters of the ocean. 2. Deep ocean currents, thermohaline circulation, are influenced by temperature and salinity differences, creating a global conveyor belt that moves water over thousands of years. Small blue diamond, B, the global conveyor belt, thermohaline circulation. 1. This deep-sea current system transports heat and dissolved gases across the globe, maintaining climate stability. 2. Cold, salty water sinks near the poles, while warm water rises near the equator, driving a continuous cycle of ocean movement. 3. This process helps moderate global temperatures, distribute nutrients, and regulate atmospheric CO2 levels. Americas. 2. How ocean currents regulate climate. Small blue diamond, A, heat distribution and weather patterns. 1. Warm ocean currents, such as the Gulf Stream, transfer heat from the equator to higher latitudes, preventing extreme cold in coastal regions. 2. Cold currents, like the California current, bring cool, nutrient-rich water to coastal zones, stabilizing regional temperatures. 3. These ocean-driven climate systems prevent extreme heat accumulation in the tropics and excessive cooling in polar regions. Small blue diamond, B, the role of ocean currents in rainfall and drought. 1. Moist air from warm currents leads to increased rainfall and storm activity in coastal regions. 2. Disruptions in ocean currents, such as El Niño, can trigger droughts in some areas and floods in others. 3. Shifts in ocean circulation patterns can intensify hurricanes, monsoons, and heat waves, directly impacting agriculture, water resources, and human settlements. Small blue diamond, C, CO2 absorption and climate regulation. 1. The ocean acts as a carbon sink, absorbing approximately 30% of atmospheric CO2. 2. Currents transport CO2 to deep waters, helping regulate greenhouse gas concentrations and mitigate climate change. 3. A weakening of ocean currents could reduce CO2 absorption, exacerbating global warming. Africa. 3. The impact of climate change on ocean currents. Small blue diamond, A, melting ice and rising temperatures. 1. Glacial melt and warming oceans are altering thermohaline circulation, potentially disrupting the global conveyor belt. 2. Weakening ocean currents could lead to colder winters in Europe, stronger hurricanes in the Atlantic, and altered monsoon cycles. 3. Rising sea levels caused by climate change may further modify ocean current behavior, impacting marine biodiversity and coastal populations. Small blue diamond, B, the threat of a slowing Gulf Stream. 1. The Atlantic meridional overturning circulation, AMOC, which includes the Gulf Stream, is showing signs of weakening due to melting ice caps and decreasing salinity levels. 2. If AMOC collapses, it could cause colder European winters, severe storms, and rising sea levels along the US East Coast. 3. A disrupted Gulf Stream could also lead to heat waves, extreme droughts, and shifting monsoon patterns in Africa and Asia. Small blue diamond, see, the future of El Niño and La Niña events. 1. Climate change is intensifying El Niño and La Niña events, leading to more frequent and severe droughts, heat waves, and tropical storms worldwide. 2. These disruptions can significantly impact fisheries, agriculture, and water resources, affecting millions of people in vulnerable regions. Crystal ball. 4. The future of ocean currents and climate regulation. Small blue diamond. A. The need for climate action. 1. Reducing carbon emissions is crucial to preventing further disruption of ocean currents. 2. Protecting polar ice caps and reducing ocean warming can help stabilize global circulation patterns. 3. Investing in renewable energy, carbon capture, and marine conservation is key to mitigating climate change's impact on oceans. Small blue diamond. B. Monitoring and predicting changes. 1. Scientists use satellites, ocean buoys, and climate models to track ocean currents and predict long-term changes. 2. Improved climate forecasting can help nations prepare for extreme weather events and adapt to shifting oceanic patterns. 3. Continued research on deep-sea circulation and polar ice melt is essential for understanding future climate risks. Small blue diamond. C. The role of marine conservation. 1. Protecting coastal ecosystems, coral reefs, and seagrass beds ensures that ocean currents remain stable and healthy. 2. Reducing overfishing and marine pollution preserves biodiversity, which supports natural climate regulation processes. 3. Strengthening global policies on ocean protection can help safeguard vital marine resources. Pushpin. Conclusion. Ocean currents are Earth's natural climate regulators, responsible for heat distribution, weather stability, and carbon sequestration. However, climate change is threatening these critical systems, with potential consequences including rising sea levels, extreme weather, and ecosystem disruptions. Understanding the relationship between ocean currents and climate is essential for developing sustainable solutions. By reducing carbon emissions, protecting marine ecosystems, and investing in climate science, we can help preserve the delicate balance that keeps our planet's climate stable for future generations.